Hello Algebra 2. We are starting chapter 2, which is going to be all about quadratic functions. And so what we're going to do in this first section is build on what you know about quadratics and the parent function. So we looked at it a little bit in the last chapter, and now we're going to introduce the standard form of a quadratic. So that's going to be ax squared plus bx plus c equals y, which you should recognize when you're using the quadratic formula. So that's your standard form. Then you also have something called the vertex form, and this is the one you tend to use when you are doing transformations. So this one might actually look more familiar to you. Y equals a x minus h squared plus k. So in that form, hk represents your vertex, and the a is your vertical dilation. And what do we call the graph of a quadratic? We call it a parabola. All right, so there's just some general info. Now let's look again at how we will be working with the transformations. And I'm gonna just kind of let you know that this B right here that is in front of, that's usually a horizontal dilation. We're not gonna be focusing on that too much in here because I want you just to have the most basic transformations. So what I'm gonna do is I'm gonna graph each parent function here. So there's your parent function. Remember that when we do that, we go over 1, up 1, and then you're gonna go over 2, up 4, because 2 squared is 4, to get those initial points, and then use the symmetry on the other side. So you always want to give the vertex and then those other points. That would give you 5 points, which gives you a nice accurate graph. So the first thing we're going to look at is translations. So remember, a horizontal translation makes you go either left or right. And so if what you saw in the equation was f of x minus h, and again, that's your parent function is your x squared, that means you're going to be moving h units to the right. So that would move you over to here, positive h. If what you saw was f of x plus h, that would move you, again, horizontal always acts in reverse, that would move you back in the negative direction. Okay, so that's your horizontal translations. Then we have the vertical. Remember, the vertical is going to move you up and down. So here's the parent function that we start with. And if what you see is f of x plus c, notice it's now on the outside, that's going to move me up. So that would be up like this, and this would move me up to c. And if I saw f of x minus c, that moves you down. So then your vertex would be down here. I'm doing a little bit larger so it doesn't run into each other, at minus c. All right, so those are the easy ones. That's moving right and left, moving up and down. Basically, you move your vertex and then you can draw your graph. Dilations is a little bit harder. When you are doing a horizontal dilation, again, so we're in the horizontal column, remember it always acts the opposite when you see the actual notation for it. So if you happen to see, so this is if you saw f of, I'm going to put this as bx. So if b is greater than 1, so like 2x, 3x, that's actually going to be a shrink by 1 over b. So shrinking means you are shrinking horizontally, so it would shrink in towards the y-axis. So that would shrink in by whatever factor 1 over b is. If b happens to be between 0 and 1, so it happens to be a fraction, then it's going to be a stretch, again, by, now remember, b is a fraction now, so a stretch of 1 over b is going to be a bigger number. So that would then pull you away from the axis. I'm not going to be focusing too much on those because horizontal shrinks and stretches in a parabola is basically the reverse of what you would see in the vertical. This is the one we're going to most focus on. So again, in the vertical, here's my parent function. And vertical works exactly as you would think it works. So it's going to be on the outside. We're going to see a times f of x. And if a is greater than 1, that is a vertical stretch. It's like when you pull your arms up and you are stretching. So that would be a stretch by a factor of a, exactly as you see it. And if a is between 0 and 1, it's a shrink vertically. So that means you're getting closer to the x-axis when you shrink vertically. So it kind of widens you up. So if you have a fraction, you actually have a much wider graph because it's shrinking down to the x-axis. Okay, and this is the one that we're going to most focus on, more than the horizontal. Then you have your reflections. So your reflections, so horizontally is when you are reflecting over the y-axis. So anything horizontal goes inside the parentheses, which means in this case, you're going to have an f of x. Now, if I graph my parent function here, and we saw f of a negative x, what happens is this branch, you don't always see the reflection, reflects over to this branch, and vice versa. This branch would reflect over to that. So you don't always see them if it's still symmetric about the y-axis. On the other hand, our vertical, so anything that happens vertical, remember, happens outside the parentheses. So this one is going to reflect over the x-axis. And so what you're going to see is minus f of x. The negative is going to be on the outside. And what happens, this is like when we determine whether the graph is a smile or a frown. So this one is going to reflect over that way. Okay? So now we're going to look at how we can take an equation and in words write what the transformation is, and then graph both the parent function and the transformed function. So in this first example here, and again, order matters, but not necessarily when everything is just a translation. So notice inside the parentheses, I don't really need this line here, inside the parentheses, I have the plus 4. So that tells me I am going to shift 4 units left. So you're going to go in the negative direction because you always do the opposite of what's inside the parentheses. And then the minus 1 means I'm going to go down 1 unit. So to graph that, and again, you are going to want to be accurate in your graphs. So we have some points here. You have 0, 0, you have 1, 1, negative 1, and you have your 2, 4, and negative 2, 4. So let's go ahead and label our axes with 1, 2, negative 1, negative 2. So what we can do is just move those points. So I'm going to take my vertex and I'm going to go 4 units left. So this will put me down here at negative 4 and down 1 unit. So that puts me down here. So my vertex now is at negative 4, negative 1. And then I'm going to go over 1, up 1, over 1, up 1. So that's at negative 5. And I would go over 2, up 4, which puts me at a 3, and do the symmetry. And there's my graph. So you're basically taking each point and shifting it. Okay? So now this second one, we got a lot more going on here. And again, order matters. So what I would always do is if there's a dilation or a reflection, I would deal with that first, because those actually change the shape and position of your graph. So let's deal with this first. So this says that I'm going to reflect over the x-axis. That's what the negative does. And then I'm going to shrink vertically, because it's outside the parentheses, by a factor of 1/2. So that's for any dilation stuff. Now notice inside the parentheses, I'm also going to shift right in the positive direction 3 units because it's inside the parentheses, and I'm going to go up 2 units because that's your vertical. All right, so let's put our original graph here. Here's our parent function. Again, 0, 0, 1, 2. So 2 is going to be up here at 4. 1 is going to be at 1. And we have the symmetry over here. So -1, -2. All right, so we're going to move some things around. I'm going to just kind of do a dotted evolution of this graph. So the first thing would be reflecting over is going to do that. It's just going to reflect me over. Shrinking by 1/2 means that instead of going over 1, down 1, I'm going to go over 1, down 1/2. So here's, let's say that's -1. So I'm going to shrink by, I'm multiplying my y values by 1/2. So this is only going to be at 1/2. And at 2, I'm only going to be at -2 instead of 4. It's going to actually be a wider graph. So how do I want to try and show that? Okay, so I think that we'll go by what we're marking here. So this is a -2. Okay, so now we also we have our new shape. We're going to take the vertex and we are going to move it over 3 units and up to 2. So here's 2. So my new vertex is going to be at 3, 2. We're going to still be going down, and we're going to go over 1, down 1/2, over 1, down 1/2, and then over 2, down 2. I know this looks like a mess. So I actually hit the axis here, and so it's going to look a little wider. And there's our graph. Okay, so notice it's a little bit, I was supposed to shrink vertically. Yes, shrinking vertically actually makes you wider. Okay, after that little announcement there, which I took us out of. So now that's how you would graph them. Now what we're going to do is, given the description, try and come up with the equation that would go with the graph. So let the graph of G be a horizontal shrink by a factor of 1/3. So remember, our parent function is y equals x squared. So we're going to do this evolution step by step. So a shrink by 1/3 means that inside the parentheses, I'm doing the opposite. So that means since it's inside the parentheses, it's substituting for the x value. So this is what I would have. I substituted for x, 3x. So that would give me 9x squared. Okay, now let's do the next thing. We're going to reflect in the x-axis. So that's going in the vertical direction, which means you're now going to have minus f of 3x. So that means the 9x squared gets multiplied by a -1. And then the last thing we're going to do is a translation 2 units up. And so that means we're going to take what we already have. Going up is vertical, so it happens outside. So I take my equation and I add 2 to it. And so my final g of x is -9x squared plus 2. That would be the final equation. And if you can go directly there without showing every single step, that's fine. I just wanted to show how the derivation happens. Okay, the next one, let G be let the graph of G be a translation 3 units right. So again, that means that's happening inside because that's a horizontal. Right is in the positive direction, so we're going to write x minus 3. Remember, inside is always the opposite. Then we're going to go 2 units up, so outside because it's vertical. So this is the functional notation. So what's going to happen is you're replacing, anything inside replaces x. So this becomes x minus 3 squared. Anything vertical happens outside, and that would be our final equation. Okay? So just to wrap it up, remember this outside number, the a, is your vertical dilation. So if a is greater than 1, it's going to be a stretch. If a is between 0 and 1, it's a shrink. And if a is negative, that's your reflection. And then the h, this is your horizontal. So remember that x minus h moves you in the positive direction. X plus h will move you in the negative direction. And very nicely, the plus k indicates exactly what you would think. Plus k will move you up. A minus k would vertically move you down. The only time I'll be giving you a horizontal is if it's in a description. I'm not going to have you graph.